This is our first lesson of Unit 2, which covers nonlinear functions, functions that do not graph lines, they graph different kinds of curves. Our first learning target is going to cover factoring quadratics and how do you factor quadratic expressions. To do this, let's recap how you multiply two binomials together. These are called binomials because there are two pieces being subtracted or being added together, and we're going to talk about how we multiply these two things. So if you recall from Algebra 1, in Algebra 1 we used FOIL. It stands for first, outside, inside, last. First we multiply the x times the x, and we get x squared. Then we multiply the x times the 8, and we get 8x. We multiply the negative 3 times the x to get negative 3x. And we multiply the negative 3 times the positive 8 to get negative 24. We have two like terms in the center. We have 8x minus 3x. Those two are like terms. We can add them together to make 5x. But the minus 24 and the x squared are still in the beginning and the end. This is our answer. When you multiply two binomials together, you get a trinomial, an expression with 1, 2, 3 terms, trinomial. One more time, let's try that again. X times x is x squared. X times negative 9 is negative 9x. Negative 4 times x is negative 4x. And negative 4 times negative 9 is a positive 36. Again, we have these two like terms right here in the center. Negative 9x and negative 4x together make negative 13x. With a add 36 and an x squared in the front. But the point of our lesson today is actually to do this backwards, to start with the trinomial and make the two binomials that would multiply to create it. The way that we're going to do this is we are going to consider what creates the 35. If you remember from what we just saw, the two numbers in the binomials multiply to make 35. So we have to ask ourselves a question. What are the factors of negative 35? One set of factors, of course, is 1 and 35, because 1 times 35 is still 35. If I try to add these two together, I get 36. If I try to subtract these two, I get 34. Neither of these are our negative 2 in the center. So this combination of 1 and 35 is not working for us. There must be another set of factors that will help us. How about 7 times 5 is 35? If I add these two, I get 12. If I subtract 7 and 5, I get the 2. Now, we need to consider the fact that it has to make negative 2. So the signs on this are not working for us. Instead, I would have to start with a negative 7 and a positive 5 to get a negative 2. So this is the set that works to create not only the negative 35, but also to add and make negative 2. Let's now set up our answer. All of our answers are going to have two sets of parentheses for the binomial. X squared is only created by doing x times x. So our problems today are going to have this x in both of the parentheses. We have negative 7 as one of our pairs of numbers that works for negative 35 and negative 2, and 5 is the other number of the pair. This is our answer. Let's try that one more time with a different set of numbers. Remember that the number at the end of the trinomial is made by multiplication. What kind of combination of numbers makes 32? So we have to ask ourselves, what are the factors of 32? One set of factors is 8 and 4. Is there a way to use 8 and 4 with positive and negative signs so that we get a 12? If I put a plus between them, 8 plus 4 is 12. So a positive 8 and a positive 4 will multiply to make the 32, but will add to make the 12. This pair of numbers is the pair that will fit. Sometimes we get lucky and find the pair very quickly. If I did not find the pair, I would then move on to another combination of numbers, such as 16 and 2. So now that I have my pair, let's set up our two factors. Double set of parentheses. Remember, x squared is made from the x times the x. And now it's time for a pair of numbers, positive 8 and positive 4. 8 times 4 is 32. 8 plus 4 is 12. Now there is a different approach. If thinking about factoring in the way that we just tried it is not working for you and seems really difficult, I have another way for you to try out. I call this the magic X. And the magic X helps us factor quadratic trinomials. But you do have to remember some rules about the magic X. If you can, then it will help you find the answers. In the top of the X, we're going to put a number that is made because of multiplication. The number that is made from multiplication is the 42. The number that is made from addition is the negative 13. Again, the 42 is made from multiplications, and our negative 13 is made from addition. Now I have a little puzzle. So on the sides of the X, I put the numbers that multiply to make 42, but add to make negative 13. So let's try some numbers. I do know for a fact that 7 and 6 do multiply to make 42. Right now this works. Positive 7 and positive 6 make 42. But unfortunately, it does not work for the number down here. This 7 and 6 don't fit my puzzle for a negative 13. They would work for 7 plus 6 is a positive 13. So in order to make the puzzle fit, let's try changing the signs on my numbers. Negative 7 and negative 6 do make negative 13. And lucky for me, negative 7 times negative 6 make positive 42. These are the numbers that I want to put into my answer, into my binomials. So now it's time to set up my answer with an x minus a 7 and an x minus a 6. Let's see that one more time. On the top of the X, we need to put the number that is created through multiplication. The number that's created through multiplication is 24. Something times something made 24 in those double sets of parentheses. Down below is the number that is created through adding the two numbers in the parentheses. That is the 11. Now I ask myself a question. What two numbers do I put here that multiply to make 24 but add to make 11? One set of options could be 6 times 4. 6 times 4 do make 24. 6 plus 4 do not make 11. These numbers fit for the top number but do not fit for the bottom number. If I try to change the signs on them, like negative 6, now those add to make negative 2. So that doesn't work. If I try putting a negative sign here, 6 plus negative 4 is positive 2. That also doesn't work. Two negatives would just make negative 10. So I don't think 6 and 4 are actually the numbers I want for this problem. There must be another set of numbers, another pair of numbers, that do make 24. Let's try 8 and 3. 8 and 3 make 24. 8 plus 3 do make 11. Check to make sure that your negative signs and positive signs are all working. Positive makes a positive number through multiplication. A positive plus the positive comes out with a positive number in addition. So this pair of numbers, the 8 and the 3, work for my puzzle, work for the magic X. So now I can go ahead and now write my answer. X plus 8 because it's a positive 8, and X plus 3 because it's a positive 3. If you like the magic X, you can definitely use it. I hope that eventually you get to the point where you can mentally think in your head what times what makes 24 and adds to 11, and be able to work that out in your head or as scratch paper. But if in the meantime you need a way to organize your work in order to find the combinations that will fit our trinomials, that will fit our quadratics, use the magic X. If you have any questions, make sure you put them into the left side column in your notes and you bring them into class.